ScoopBoxTv NASA Science, Watch Water, and Alka Seltzer, in zero gravity. Welcome to ScoopBoxTV, citizen of Earth. Today, we have official NASA footage of Alka Seltzer and water aboard the International Space Station. So, let's get this show on the road.
The subject of this Saturday morning science is heterogeneous bubble nucleation. And in order to show this, we need to have a couple of spheres of liquid. And now, to make these spheres of water, we're going to first start off by making a two-dimensional film. And here I'm adding water to that film so I can inflate that thin film into a sphere of 50 millimeters in diameter. And I hope you folks are trying to guess what's going to happen. Right? What's going to happen to the roll of all of these bubbles that are going to be released. First time I did this, I had no idea what was going to happen. I had a couple of preconceived ideas, and both of those were wrong.
Well, that's what science is all about.
It just goes to show that sometimes you just have to do an experiment in order to figure out what's going to happen. And of course, what we're seeing here is salvation to zero gravity heartburn. Now, that was so interesting. We're going to watch this again, only this time from the side of the little wire hoop, and pay attention closely to the fate of the bubbles as they get generated. And what I see happening here, you see the chemical reaction developing all of these little tiny bubbles, and there's enough momentum because the bubbles are being kicked off from a solid surface for the bubbles to collide, and they rapidly collapse and make bigger bubbles. And then these big bubbles start to swallow up other bubbles as the chemical reaction proceeds until ultimately you're left with 2 or 3 large bubbles with hordes of little tiny bubbles. And as the chemical reaction proceeds, it starts to slow down. There's no longer enough kinetic energy to cause the bubbles to coalesce. And here you can see we basically have 2 great big bubbles that form this bipolar arrangement that seems fairly stable. A situation like this will last for some time unless it gets popped. And here all the little bubbles have been pushed in the spaces between the 2 big bubbles. Now, and there, one of the bubbles was popped, and so now we have a sphere that's basically hollow inside. It's a big gas bubble inside. Now the rhetorical question comes about how can you remove all these bubbles and get back to a sphere of liquid again? And so here, we're sticking in a syringe and sucking out the air. And as this happens, the whole system shrinks in volume. And you keep withdrawing the air until you can see that liquid is starting to be withdrawn from the syringe, and then you've gotten the big air pocket inside. And now we're left with a sphere filled with all these little tiny bubbles. And what you can do now is you can start to stir it here with this Teflon cannula, and you can get a rotation motion started. And as we've seen in previous Saturday morning science demonstrations, a rotating motion causes the bubbles to go to the center in this tornado-looking core. And then you can stick in another cannula, and you can remove the bubble core. And here, the last little collection of fine bubbles in the core are being removed. And here's that thin film on a wire loop. In this way, we're going to watch an effervescent tablet starting off in a two-dimensional liquid film with very little water, and watch the fate of what happens. And you can see that the volume expansion is quite significant here as it takes a small amount of water and liberates the gas due to the chemical reactions involved that make the CO2 gas, and the resultant bubbles expand the whole system. The fate of bubbles in liquid is an important topic for operations in zero gravity, whether you're designing a science experiment or whether you're designing a piece of engineering equipment which is supposed to operate in this environment. And it's really important to understand what happens to gas in liquid and liquid in gas to understand the dynamics of what's happening. And I'm hoping this demonstration will give folks ideas for what might possibly be happening in their systems, and maybe some new experiments can come out of it. And here it looks like the effervescent tablet is, the reaction rate is limited by the supply of water to the tablet. Because it started off in this thin film, the tablet's not completely surrounded by a large volume of water. And you can see here that the chemical reaction is dramatically slowed down as the bubbles are slowly being generated next to the edge of the tablet and moving off into the film. And again, it's possible to have chemical reactions where you are limited by the rate of reactants going into the system, and it looks like that's happening in this two-dimensional film case, in this thin film case. And this concludes our Saturday morning science for the week, dealing with heterogeneous nucleation of bubbles and the general fate of bubbles inside liquid bodies.
Don, that was spectacular. We're happy to announce that your Nobel Prize will be waiting for you at your landing site in Kazakhstan. We're also very pleased to see that you have Alka Seltzer to burn even after working with us for 4 months.